Hello everyone and welcome to the Micro Frontends Meetup September edition. I hope you're all very well and you're all eager to learn something about Micro Frontends. But before we dive in, as usual, we have a couple of organizational things to go over, so bear with me for 1 minute. As you all know, this session is being recorded and also made available on YouTube. The URL for the recording is the same that you're currently looking at it at YouTube. And it will be a public video. So therefore, if you don't want to be part of that video via, I don't know, your chat messages, please don't write any chat messages. But otherwise, of course, we always appreciate any kind of activity in the chat. So if you have any questions, always just write them in the chat and we will answer them during the session. Also, the URL is made available on the meetup.microfrontends.cloud website. And of course, we also share it on LinkedIn and the other channels that you have access to. Now, regarding the chat also, as you all know, we have a code of conduct. If we want the short summary for it, it just means be gentle and polite, don't harass anyone. There can be different opinions, and we are here to discuss things and learn all together. So don't be a dick, so to speak, right? And talking about if you have a good story to tell, if you have some experiences with Micro Frontends, maybe even if your last project with Micro Frontends didn't go so well, we are all ears and want to hear your story. So please tell us about your journey towards front-end scalability. We have an official call for papers page, but we also, of course, have the possibility to just, via personal contact, invite you to the show. So if you have anything to share, always just get in touch. Even if you say, well, it's just a small story, it doesn't fill a full hour or something. I mean, we can talk about anything. So just shoot, and we will find a way. And together we all learn from our, of course, successes, but also our mistakes. So please. Finally, some advertisement. Our last, I think, workshop for this year has already passed, our last public workshop, but we're still, of course, giving workshops for companies. So if you, let's say, already have a problem, want to learn more, for instance, about module federation, maybe something with module federation version 2, maybe across bundlers or something like this, always get in touch with us, and we will find a way to provide you the right knowledge for your Micro Frontends project. And with that being said, let's welcome our guest for today. I'm not alone, luckily. We have a very special guest today. We have Devon with us, who is a tech lead. Hi.
Hi, Florian.
How are you doing?
Yeah, doing really good. So I would like to really thank you for inviting me for this meetup. I think it's really exciting.
Yeah, for a little bit of context for everyone to know, Devon wrote a really great article about using a Micro Frontends framework called Pyro together with Blazor. And this will be also, of course, the topic for today. And I think you've done it for a client project, but you also, and this is what we will see today, created a really nice to follow sample project where everyone who's interested in using Blazor with Pyro can just, get started and already has a really great starting point, right?
Yeah, of course. Yeah, so I wanted to create something that is reusable for the community, and it'll be easy to get started.
Nice.
So I think in this meetup we'll go through the article which I've wrote, and I'll go through what I have learned while doing this. So I think it will be a good experience sharing session.
Cool. Then I would say let's get started, right? The stage is yours.
Awesome. Okay, thanks, Florian. As Florian mentioned, so just a brief introduction about myself. So I'm currently working as a tech lead at a company called 99X. So I mostly work with front-end technologies like Blazor and also React and React Native. And also this micro front-end architectures is a really interesting area that I find. And so recently, the main reason I got into this field was I had a requirement where a client required to build micro frontends using Blazor server hosted model. So that was the main starting point where I started exploring about micro frontends, and actually found this amazing framework called Pyral as well. Yeah, so we'll dive a bit deeper into this. So just to start off, just to give a context, like I know this is a bit basic, but like when it comes to micro front end, it's all about building smaller modular like front ends that can be plugged in together to build the end user application. So this building in this manner, which really helps larger organizations having larger products to easily manage these products in a modular manner. So that's the main inspiration behind micro frontends, and I think large, especially very large products, really find having micro frontends really helpful. um, I think like some of you may be new to micro frontends, so there is like enough resources or like to learn about the basics of it. Yeah, so this is one such video I have linked here. But when it comes to like architectural patterns when building micro frontends, like there is actually two main patterns. So the two main patterns are actually compile time composition pattern and the runtime composition pattern. So we need to understand these two before we go ahead. So like if we look at the pattern one, so that is the compile time composition. So as you can see in this small sketch I have in this article, so basically in compile time what happens is you have different micro frontends, the source code maybe in separate repositories. So in build time, or in other words in compile time, that all those front ends are compiled together, bundled together into one yes, one bundle, and that is deployed. So that is so the composition of the final application is done in build time and not in runtime. So that's the main idea behind compile time composition. Like anything, so all have pros and cons. So in this case, so in terms of performance optimizations, it actually can be good. It happens in build time, the composition happens, so in runtime there is no composition happening, so there can be performance gains there, and deployment will be again a bit simple. So will be very similar to deploying a monolith as well, with few changes. And yeah, so consistency maintenance is would be a bit easy, because like finally bundled thing will be visible, like easily deployable. So the cons of it would be it is a bit yeah, it's not very flexible. So it, like say, changing a single part of it or a single micro frontend requires bundling or compiling the whole thing altogether in this scenario. So that's not a good thing when it, especially for large applications, can increase build time, and you can't like modular like scaling and those things can't be done. And yeah, longer build times, of course, since everything should be built together, and dependency management can be a bit of problem. And again, scalability wise, when a lot of micro front ends are there, it can be an issue. So coming to pattern two, so pattern two is a bit different to pattern one. So pattern this is runtime composition. So if you look at this again, so you can see at build time the front ends are merged together, compiled together. But in runtime composition, what happens is it will actually have these like source code um, like compile together during runtime. So it's more dynamic, more flexible, and it doesn't have like a pre compiling or like a build stage where these things are compiled and then deployed, but they are deployed separately, and it's compiled together. So that's one thing. So like compile time, this also has pros and cons. So first thing, pros wise, it's very flexible. Like individual front ends can be updated independently without affecting the rest. So it's very easy if you want to make a change only in one micro front end, that can be done. Scalability wise, it's better. And yeah, dynamic loading. So this is basically like if on runtime, if you want to change something dynamically, since this is runtime compilation, it is possible. And yeah, deployment also, it's good, but I think it's not very different when it comes to deployment, when it compares pros and cons. But when it comes to cons, there can be performance overhead if you do not properly do it. Uh, but if you do it properly, I think that can be avoided. And orchestration, if you are going to do everything by yourself, that can be complex. But if you use a library or a framework, I think that can be simplified further, because yeah, so Spiral is one such library, so but we will talk about it. And versioning challenges can be there, and there can be security concerns as well if it's not managed properly. So those are a bit of like high level cons that we can like explore further. Yeah, so those are basically two patterns. But before I dive into the Pyro framework and the actual like the proposed architecture in this article, I want to give a quick refresher on Microsoft Blazor for those who have not worked with it. So Microsoft Blazor is a technology from Microsoft, of course. So it has actually multiple hosting models. So like by hosting models, what I mean is how it runs. So first one would be the server side model, next one would be the WebAssembly, and there is a hybrid model that uses both. So in the server side model, most of the heavy lifting is done in the server side, and in terms of WebAssembly model, it happens in the browser using WebAssembly. So in this article, the focus is towards server hosted model, where this micro front ends are built using Microsoft Blazor server hosted model. So that's a quick note before going deeper. Yeah, so next,
Yeah, maybe
yeah.
one. Yeah, I mean that also, of course, because you have these different modes, right? You can just go fully client with WebAssembly, fully server. You can also now do a really nice hybrid mode. I think this also plays a little bit into. I mean, for the compile time composition, it doesn't have much impact, right? For the pros and cons, but for the runtime composition, of course, that shifts a little bit some of the pros and cons. So, for example, I guess, for instance, performance isn't as significant, let's say, a loss if you talk about an overhead of microperformance when you do it a server versus a client, right? Because on the client, you would actually care if it takes, I don't know, instead of 1 second, 3 seconds or something like that. But on the server, if it's only, let's say, noticeable on a server start, then, I mean, you don't care if it takes 20 seconds or 22 seconds or something, right? So the server start, I mean, it can be a little bit delayed, or some of these things don't matter as much as beforehand, right? Or do you agree, or what is
Yeah,
your
yeah.
opinion?
I think that makes perfect sense. I agree with that. Awesome. Yeah, thanks, Florian, for that. Yeah, so moving forward, the Pyral framework is what I have been utilizing for this proposed architecture as well. So talking a bit about this framework, it's actually a really like a nice framework. So this is not only for Blazor particularly. This is can be used with like even different technologies, even if you are building micro front ends with React or other uh, like various front end frameworks. This is useful, but in this scenario, it was very useful to me while building Blazor based micro front ends. Yeah, so I think maybe Florian, if you want, you can give a bit more depth into talk about Pyro framework a bit.
Yeah, sure. I mean, we can just spend let's say, a little bit of the thought process behind. I mean, you have this nice diagram presented here. So the basic idea is to, let's say, take all the foundation that you think of when you think of micro frontends, that you, let's say, want to have independent development and of course independent deployment and all that, together with, of course, the usual constraints that come up in such projects. So constraints like, but we want to have a singular design system applied to everything, that, you know, there should be a UX consistency at the end of the day, or you want to have certain capabilities that are being shared because they are core architectural concerns, for instance, authentication and things like that. So what Pyro does as a framework, it provides you a basis to actually write an application that is in its heart modular, using what you could think of as a plugin based approach. So teams can then develop, you can call them plugins, you can call them microphones, that's what we call them, or in the context of Pyro, you usually call those things pilots, but it's all referring to the same thing. So it's an independent unit that can then on application start. So in the case that Devon is describing here, on the server start, for instance, but it could also be when, you know, and the website is hydrated and is going live in the browser, can then obtain more code in form of, I don't know, pages, individual components, menu items, whatnot, whatever is now in this container that we call micro frontend. And this forms then a really nice thinking process, because you have already an architecture that is, let's say, very well isolated, forms these boxes, is highly modular, but it still forms this consistency and this easy sort process of having a flat hierarchy, so no deep nesting of these things. And that just makes everything easier, I would say, to debug and think about than, let's say, in a deeply nested distributed system. It's, of course, it's no monolith still, so things get more complicated naturally. But if you develop an individual modules, and that's the key idea behind it, then things should be rather simple and flexible for you as an individual or individual team.
Yeah, I think that really sums it up. I think so the key features I mentioned here also, I think like Florian covered right now. So I think like personally, I actually really this actually really helped me and made my life so much easier. So if I had to do certain things that is there in the framework from scratch, it would have like taken me such a long time. So yeah, so that's the main reason. Again, I like was going like stick to using a Pyro framework for this solution as well. Yeah, so moving on, so the proposed architecture. So this is the architecture that I have like come up with comes into play. So so just hope you guys can see the whole thing. Let me see. Yeah, okay. Yeah, so basically if we talk about Pyral Blazor, so Pyral Blazor actually provides with a NuGet package that helps to orchestrate like micro frontends in runtime. So how it works is for example, say you have multiple teams working on multiple frontends, micro frontends. So you can have all of those projects in different repositories, and then each team can be working on them independently. And also you can have one shell project that is like going to be loading in the micro frontends in runtime. So basically you can set up your own CI/CD pipelines, like so in this example, like I have used GitHub Actions that can actually deploy these micro frontends. And also I have utilized the Pyro Cloud. So Pyro Cloud is actually a service that actually helps to deploy, publish these micro frontends that we build, and it really easily helps us to manage these micro frontends, including versioning, and also it has feature toggling and enable disable micro frontends. And also it has things like setting rules on, like say if you want certain micro frontends to render at specific times or like things like that. So there is a lot of things that can be done with Pyro Cloud. And also, if you are not like if you don't want to use Pyro Cloud, they also provide a Docker image that can be actually have an instance of this in your own infrastructure as well. So that's also a cool thing. Like in this flow, basically the micro frontends are developed by a team, and then it is connected with a GitHub action or a pipeline that will publish the micro frontend to the Pyro Cloud. And how it happens, like how it loads at runtime, is basically the shell application. So the shell application is also built separately and deployed to your preferred cloud infrastructure. So in this case, Azure Cloud is used. And so that hosted shell application will have the Pyro Blazor orchestration setup, where it will actually pull in the micro frontends from the Pyro Cloud using a discovery service and a feed that is set up. So if I just show you a little bit on how the Pyro Cloud looks, so it would look something like this. So here, like once you have so you can configure certain feeds here, and once you have a feed in, so you will get this feed URL. So that so there is that will help you to get these feeds. And so when you publish micro frontend, so it will actually appear here, and you can see you can enable disable them as well. And if you go inside that, you will get some information about that, the version number and uploaded date and things like that. And also you can delete them. So this will help you manage it in like admin level. So that's this part of it. And then this is actually where the actual user facing application works. So here these micro frontends are published as NuGet packages, and that is what is pulled in over here. So I'll move on a little bit faster. So in this, I think we can share this article with you guys, so we can go a bit more like in detail and go through the steps. But in this article, like I have explained about this, like how we can actually achieve this. And I think we can look at the starter project a little bit that I have built. So in the starter project, this has integration already existing with Spiral framework, and some steps on how you can get started as well. All right, let me open that up. Yeah. So if you look at this project, hope you guys can see. Let me zoom it a little bit. Yeah. So if you look at this project, so in this project I have a main shell application and two micro frontends. So I have the running application right now. So this is how it looks. So here these two are actually separate two micro frontends. So this first one is like a very simple count application, and the second micro frontend is like a weather widget card. So this one actually pulls in data from like a public weather API just to display it. So like it doesn't matter what you build, you can make it into a micro front end. So like how this is achieved is basically, so we have the main shell project and two micro front ends, as you can see. So the micro front end one is the counter project, and this one is the weather project. So if you look at the shell application, so if you go to the app JSON, so we have to do a bit of configurations here. So this is where this feed that you uh, create comes into play, where you have to give the feed URL to the discovery URL. So behind the scenes, the Pyro framework will use this to pull in the micro frontends. And also, if you look at how what happens in this, so if you go to pages and dashboard, you can see again another library, like a component which comes in is the Blazor shared, where we can use this MF component tag, and you can load in the micro frontend. So these things play as slots basically. So whatever you like expose as micro frontends, we can actually use here. So where this name comes from is basically where you define it in your micro frontend. So if you go to micro frontend and you go to module.cs, so here in the setup you can actually map components out of your micro frontend. So this, the beauty of this is, it doesn't have to be like a huge container or a big application. It can be even a small very tiny button, even you can expose like this and use it anywhere. So like it's very flexible and modular, so that's a really good thing, I would say. Then like, so all you need to do is in your micro frontends you expose it like this, and then in your main shell application use a slot wherever you need to use it. Yeah, so that's kind of basically the high level explanation of this project. And of course, if you look at I think the Pyral Blazer, yeah, so it's really well documented here as well. I think it's not this one. Yeah, it's this one. Yeah, so here I think all the setup steps and things are actually well documented. So this is the server setup that I have been using. So there's few things actually to do, but in this template these things are already done. So it's just you have to create your feed, and I think the steps are mentioned here. So you create your feed, and then you link it up, and then you can actually start off with this template. um yeah, so if we, yeah, in this step, like for example, in this architecture, like you can see in here there is a pipeline set up to publish to Pyra Cloud. But say if you are in a just the starting stages, you don't have like a CI/CD pipeline, you can actually use a command provided by the CLI to actually publish this micro frontends to Pyra Cloud. So I think that is also explained in this article. So with this, you can publish, like build your micro frontend and publish it, and it will appear over here. Yeah, so that basically sums up what I had to present to you guys today. So probably if you guys have any questions, or if Florian, if there's anything you want to add, I think we can discuss now.
No, I think that's all quite good. I mean, what you I think also mentioned, of course, so this feed, of course, where you used the Pi Cloud, and I mean, you said you can also run this, of course, as a Docker image on premise is great. I mean, you can, of course, also just create your own, right? This could be also a possibility, though there is no. I mean, this is all well specified, so you can just, if you're really eager, develop your own. We, of course, as Smart here, or as the core maintainers, we would like, of course, everyone to use the official one. It also has some advantages, but of course, if you have, let's say, very custom requirements, or for whatever reason cannot, I don't know, use third-party software, you can just develop your own. And it can even go so far where you say, hey, I want to do runtime composed micro frontends, but I'm not yet there to, let's say, have a full service for that, right? So you still want to compose at runtime, but essentially you still make some shared build step, let's say, to, for instance, update a JSON file just somewhere. So you can also do that. The only requirement at the end of the day is that this kind of feed that you have, that you use, returns us either as a valid NuGet service response, or just returns a list of NuGet packages. And that's pretty much everything that we need, because then Power Blazor server is capable of just, downloading the NuGet packages, finding out where the NuGet packages, what kind of dependencies are in there, getting the dependencies, and just loading your micro frontend using this information. So it works even if you, let's say, remove or exchange this one component. But I mean, as Devon mentioned, I think it's good to have, especially because it just gives you so much more capabilities, rollbacks that you can do, rules that you can apply, a lot of things that are now possible. You can even use then in the future then techniques with AI that makes variations of your components and introduces automatic A/B tests for you. So really a lot of convenience and just capabilities that you otherwise, if you make something static in that whole pipeline that you create there, we would struggle to use. But yeah, so that's just the one thing I wanted to remark. Maybe a last thing. What you can you open the settings, the app settings from the app shell, just briefly? Yeah. So yeah, there I think. I mean, this is all done well. It's all good. That I think there are some conveniences now there. I guess the public NuGet feed is anyway always included for you. I'm not sure though, so it might be that you need to be explicit, but I think it's also there. And the discovery update URL, I think you also don't need, but I could be also wrong here. I think it automatically infers from the info URL that it can use, or it just tries to use a WebSocket. But I mean, you make no mistake if you are, let's say, explicit here. So this is anyway well done, but all I wanted to say is that I think you can make the same thing a little bit shorter. I mean, at the end of the day, being explicit in configuration is never a bad thing. Just I think we got a little bit of convenience in there. Maybe not really well documented convenience, but but that's yeah. But otherwise, yeah, I really like the sample. Of course, one more thing to mention on the sample. I mean, it creates these components. What you can also create is distributed pages. But this here, it is all on one page. And what I like about it is that usually this is the more complicated case, right? So what is usually quite simple in Micro Frontends is, that you use a microphone to have one page, and then you go maybe to some other page, and that's now from another microphone. And then you go to a third page, and that's shown from a third microphone. And yeah, that's it, right? But I mean, honestly, you could always in the past create just different websites and host them on the same server or whatever. And you had then 3 different pages from 3 different teams, so to speak. But so what is really interesting is to bring together components from different teams on the same side, and that's why I like this. And of course, it's now one empty page, and then we have these 2 components. But naturally, you could of course think that the second component could be also inside the first component. So the components can of course be nested, because this MF component that Devon showed, I mean, it doesn't matter if you use it now in the application shell, in the shell project here, or if you use it in one of these micro frontends. And so it's already reusable, the component, and it's great. And yeah, you could also, by the way, have a third line here. So MF component, microphone 1, microphone 2, and microphone 3. And the application wouldn't break, right? I mean, it's there would be nothing in there. And potentially you want to define a fallback, what's shown. But in general, this is one of the benefits of having a loosely coupled architecture. If there is nothing, I mean, it will never just fail and say, oh, by the way, the thing that you expected and that was there last week when you had it composed at runtime, that's no longer there because the team deployed. This can't happen. And so it's really loosely coupled up to the sense that it's resilient already from the get-go. So I think that's quite a nice property of the system. It really tries to make the loose coupling easy to use, in my opinion. And that's what it is all about.
Yeah, I think I totally agree with that. I think one main factor for deciding to go ahead with the Pyro framework was the loosely coupledness and the flexibility of actually defining either small or no matter the size of the component, we can use this approach, and we can slot in these micro frontends anywhere you want. So that's the main factor that I really like.
Cool. All right. So I don't see questions at the moment from the audience. So, I mean, please, guys, write in the chat if you have one or the other question. Maybe then a question from my side. What would you say is was the most complicated thing to develop? And when you came up with the architecture as designed here. And of course, I mean, the sample, of course, you did after first steps, but maybe getting into the framework, getting into microphones in general.
Yeah, so like what was a bit complicated in this scenario was for my when building micro front ends, I found enough resources for using frameworks like React, Angular, and like those common front end frameworks. But for Blazor, actually, it was quite a bit hard for the server model. It was a bit complicated. But that is actually before I discovered the Pyral framework. So after that, it was quite easy because I like the documentation was good, but there was a bit of things that were missing, that I had to figure out. But overall, the experience was smooth getting this sorted, because another challenge was I was when starting this, I was a bit new to micro frontends and the overall the architecture and the space as well. So that was another challenge that I faced. But I think overall it was a good learning experience, and of course I keep continuing to learning this area because it's super interesting.
Cool. And for the sample project now, I mean, would you let me phrase it like this? Would you agree that the most complicated part is usually setting up the solution as a whole, but then of course creating, let's say, individual microphones is rather, I mean, wouldn't say maybe a piece of cake, but really straightforward then? Or what's, I mean, how, where would you say is, let's say, the shift in complexity? Because I mean, sure, a distributed or a microphone solution is more complicated than a monolithic counterpart, but then of course every team member, so at least that's my experience, in such a monolith, right, gets all the same cognitive overhead, independent if you're like the big chief or if you just work on a little feature. Potentially you get in touch with like everything, and that means it's quite, can be quite overwhelming, right? Whereas here, I mean, usually the feedback we get is working on the individual micro front ends. I mean, that's simple compared to if it would be like this really large monolith, right?
Yeah, so so my input would be this actually does the main architectural setup you need to get started, and it will be easy to add new micro frontends, but based on your use case and how you are going to, what kind of project you are going to do, it depends. Like I would say some of the complexities come when especially when you try to share the states between different micro front ends and things like that. It can get a bit complicated, but like if you manage it properly, I think that those things can be avoided. Yeah, so I think overall, like with this template, you can get started with it, and like as a beginner to this, I think this is a good template. And of course there is so much room for improvement, so this is a public template, so I would like much appreciate if people if you have anything to contribute, please do contribute to this open source repository. Yeah, I think it can be easy to implement new micro frontends, and yeah, you'll get challenges as well based on yeah, the use cases.
Nice. Yeah, I also think I have another remark regarding the cloud service. And I'm not sure if it's in the article, but I think it's an important remark. So right now, the that you get directly get this NuGet feed, which you might want to use, right, for the microphone and integration pipeline server. You will need a premium account. Now, don't worry, right? If you really want to try it out, just write me a message. The LinkedIn is also in the chat, and then we can also, of course, get you with a premium account, or maybe even better, we can also get you a trial version for the on-premise of the Microfront Discovery Service. So then, yeah, you can anyway already try it out in your environment, and your environment can also mean your Azure subscription, your AWS account, whatever, wherever you want to run it. As mentioned from Devin, it's just a Docker image, so you can pretty much run it anywhere as long as it supports Docker. All right, so that's really good. Unfortunately, I don't see still some question. Maybe this is one of the last chances, because otherwise we will close today a little bit earlier than usual. But maybe one more thing to share is, of course, the outline, or where the roadmap of Pirate Blazor Server, right? So this is still a fairly new project. And what we are doing right now is we wait for another project, which is called Picard, which is well, some people have asked if it's the successor to Pyrel. No, it's not. It's just a very nice base library for Micro Frontends, so JavaScript-based library. And we will actually include it in Pirate Blazor Server, because, I mean, even though this runs mainly on the server, right, you still might want to have something on the client. And that can, of course, start with hydrating things. So it will allow us also to integrate, I don't know, your React-based Micro Frontends in your Pirate Blazor Server, which is quite nice. And this also allows us, of course, to have a better, let's say, debugging experience in the browser. I mean, I think right now this already has an integration with the Pirate Inspector, which is a free browser extension that you can use. So that works, for instance, for Pirate, the standard framework, but also works with Pirate Blazor Server. And once we switch the JavaScript here to Picard, it will work even better. So there will be some more things unlocked here. So that's what we are waiting for, that we get finally a version of Picard that we can use for it. We are quite close. And then we will also move forward with Pirate Blazor Server. And we still anticipate to reach a 1.0 version of it within this year. And so then you can just use it in production and be happy with server-based or server-rendered microphones using all native Blazor or C#.NET, if you want to call it like that. Yeah, so that's the roadmap for Pirate Blazor Server. And of course, I think you were briefly on the side. We also have Pirate Blazor, and that's the whole WebAssembly-based approach, which is still just using the JavaScript core framework that we have in Pirate. And the long-term story is that all of these things will pretty much converge, meaning that you can still, of course, just do WebAssembly and use it in the browser, but it will not be so different to the Pirate Blazor Server, and it will all, as already mentioned, also work with React-based microphones and whatnot. So that this whole thing is not different islands, like we have the Pirate Blazor Server island here, but they can all, at least the microphones that have been created can be used here, there, and whatnot, and they would just keep on working. So that's the long-term goal, that you have really, really great portability here of the code that you create. So increasing the reusability implicitly and keeping the old strengths. Yeah, that's a little bit the mid to long-term goal that we are talking about. Which is the story all with Pirate version 2, right? Which also uses Picard under the hood. Now you see why Picard makes such a huge difference to use here for Pirate Blazor Server, because that is just then the source, the secret ingredient that they all have in common. And then, yeah, you can just use whatever as a basis for your app shell. Here you use Blazor Server. In another instance, you use React, as you maybe do now, or you use an Angular-based application, and then all you do is just include one more reference to Pirate, and voila, you have now officially unlocked the possibilities of Micro Frontends in your application, and that's where we are going actually with this. But yeah. All right. For me, it's no problem to end a little bit earlier. Anything else to share from your side, Devin? Because otherwise, I would say let's call it a day.
No, Florian, I think I covered what I had in mind today. So
awesome.
if there is any questions, you can take it up. But I don't
Yeah.
think there is.
Always just write Devin. He's also very active on LinkedIn. And yeah, the link to the article is in the chat. So if that interests you, look there. You can also comment on the article at Medium. And then I would say I wish everyone really pleasant days. Thanks a lot, Devin, for the great presentation. It was really insightful. And I think the Starler template is super useful. So much appreciated also the community. And then I hope to see everyone again next month when we have the October meetup.
Okay, thank you, everyone.
Thank you. Have a good one. Goodbye. Bye, everyone. So let's call it a day. I wish you all a pleasant afternoon now. Bye.